is all right. So welcome to today's class. So today will be a continuation of statistical distribution. An emphasis will be on simulation. So everything will be software driven. We won't be looking at the theory behind the simulation, but we will use our Excel and also quick fit distribution, quick fit software. And then I want you to explore other softwares. You can use R, can use Python, any other one that you are comfortable with. So I'll be sharing my screen now, and then we will simulate from uniform distribution. Are you set? So I'll be making use of the data analysis add-in that we have activated. I hope you are watching my screen. So we'll go to random number generation. Are you seeing? Yes. So select random number generation, and then you click OK. So it takes you, to that pin. Are you seeing it? Yeah. Now the distribution is the third option there. You see my mouse moving? Yes. So in the distribution, we have discrete. You can select. These are continuous. The uniform is continuous, normal is continuous, Bernoulli, binomial, Poisson. So, so let me start with the uniform distribution. So I'll select uniform. So what's the name of the variable? Let's just call it uniform variate. So I can type it uniform variate. So what I want you to do is to be repeating exactly what I'm doing. So I want you to repeat so that you will get it from here. So just type uniform variate. Uniform variate. Have you typed uniform variate?
Under where, sir?
Under the number of variable. You can see that I'm doing it. So I want you to just follow exactly what I'm doing. Watch the video. You can minimize it. So under the random number generation, that's what I selected. Then it takes me to this environment. The third option under distribution, there's discrete there by default. I changed it and I chose uniform. I want to simulate from uniform distribution. So I chose uniform. Have you seen it? So, and then it's asking number of random number. How many data points do I want to generate? How many? So let's say 500. Do you get it? Just type 500. Now, uniform, remember under the name of variable, I said put it as yes. Now, for us to have exactly the same result, we shall fix the seed, the random seed. Let's just put any number. Let's put 34 there. Random seed. Let's put 34. So if we have the same random seed, it means that all of us will have exactly the same output. But if we leave it open, what you generate will be different from what I generate, and then it will differ. But it will not generate purely at random. Now, I want to simulate from uniform 0, 1. That means the minimum is 0, the maximum is 1. Do you get it? So output. So I want to specify where the output will be. I don't want it to create another worksheet. So I hope you are watching me. So I'll click on this output range. Sorry. Oh, number of variables. Sorry, it's not name. 1. Okay. Number of variables. 1. Sorry. Then the output. Please watch the output range.
Sorry. Okay, prof. I've done it now. All right, bye.
The output range.
Is it?
No. I'm teaching. So I will click under A. Have you seen it? I'll just go and click on that. That means I want my result to start printing from that point downward. So that's all. If I click OK, it will generate 500 data points from uniform distribution. So you can check whether you are up to 500 or not. Now let's do another option. Let us assume that I have 3 different cost components into my expenses. Maybe office expenses, car maintenance, and maybe miscellaneous. And that your experience have shown that each of them is uniformly distributed. So you now want to estimate your expenses. So you will simulate for office expenses, you simulate car expenses, you simulate miscellaneous, and then maybe you add up to now get your total expenses. So this time around, the number of variables will now be 3. You get it in this case. So let's redo what we have here, and let's make it 3. And then the third attempt will now be that we will change the parameters of our uniform. Remember here we are still looking at uniform 0, 1. So what if it is uniform 5, 10? Uniform maybe 8, 22 or something. So we do that. So let's go back and redo this random number generation. So I click OK. So this time around is asking how many variables. So I put 3. Okay. Where do I want my data to start from? Let me put this into do not stop so that I don't have. So where do I want my results? I want to from C, so I can just click on C there. Do you get it? That it will start printing from C. So then I click OK. Now what do you notice? They have 3 different sets.
Yes, because it's 3.
Because you have said how many variables? 3. If I want 10, I also specify 10 to simulate. So if you check your result, it will be exactly what you have on the screen. Now I want you to remove that 34. Run it again. Remove that 34, all of you should remove. And start printing from G. So, and then the 2 of you should compare your results. And let's see. Okay, so let me also remove my own 34. So that means I'm not fixing the seed now. So,
Same parameters.
yes,
Same random.
yes, but where to start printing is different now. We're printing from G. So look at what I have. It's 3. The seed now I have removed. Then the output range, I'll delete and I said start printing from G. I hope you are seeing it. So I have deleted the random seed. So if I click OK, of course, my own will be different from your own. But yeah, check the output.
I don't. My same number we use that.
It's the same.
The same thing.
The same thing what I have.
Yes, sir.
Something is wrong. But the seed was supposed to be the one that will fix it, while that. So that's how to simulate from uniform distribution 0, 1. Excel also has an inbuilt function for it. So let's check that before we simulate from other distribution. Now I want to simulate. Please watch what I have on K. I'll type equal to the function for simulating from Excel distribution. Sorry, from uniform distribution 0, 1. That function is rand. Open and close. So just type rand, just watch. Rand, open and close. Have you seen it? You just type enter. And then you can drag to as many of that simulation that you want. So if you want 500 simulation, you will drag down up to 500 times. If you want 50,000, you will drag down 50,000 times. Yes.
So if you are going down, like the way you drag down all the way to number 20,
Yes.
if you continue from that number, will this start at pressure like to continue?
It is just generate. In fact, anytime I type enter, the value will be changing. Now look at what I have there. 0.88. So once I type outside, if I type enter, it will change.
What I have here is different. The starting point is not 0.865. I have 0.845. What I have here is 0.845. The first one. The first
0.845.
845. Not 0.88. Yes, sir.
it is different now.
Okay, okay,
You are all simulating from different engine, so the value will not be the same.
okay, sir. Okay.
The values will not be the same. It will be changing for every operation. No, the only way you can get uniform answer is to use the other add-ins and then ensure that you fix the seed. So if we are all generating from the same seed, you will have our result. All right, so now let's simulate from another distribution. Okay, still on uniform, but let's change the parameters now. Let's change it from 0, 1 to maybe 2, 8, 2, 8. So which means that the minimum will be 2, the maximum will be 8. So it will simulate in between. Yes, so that we have the same result. So again, I'll go to my data analysis, random number generation, still on uniform. I would just want only one variable. Then between now, 2 and 8. And then the seed, let's fix it to 64.
Sorry, Prof, sir.
Yes, go ahead.
I don't know how this dialog box is coming up, the random number generation dialog box.
That means it's just late.
I think at the beginning I didn't catch up then.
No. The dialog box came up after we selected random number generation. This is add-ins. No, add-ins. Oh, so I understand you have not even activated your add-ins.
Yes, sir.
The class. So maybe you have to meet your colleagues to put you through.
Okay.
So 2, 8, and then so the output I want it to be on M. So let me delete that, and then I click on M. I want 500, so I click OK. So it has generated. Okay, so for the sake of your colleague that have not activated his add-ins, so let me just put you through the process of activating the add-ins. So the first step is for you to click on Files. Once you click on Files, then you go to Options. When you click on Options, you see the add-ins there as one of the available options at the left of the pane that proper. So you select add-ins. Once you select add-ins, there is this Manage Excel add-ins. Manage Excel add-ins. So you click on Go. Once you click Go, then you will have some options for you to choose. You can select all of them. There's nothing bad in it. And then you click OK. Okay, when you select all of them, you click OK. So once you click, and then it will run depending on how fast your system is. So if you click on Data at the top menu, to the extreme right, that option that you have selected will come up, Data Analysis. Now I want you to confirm that you can see data analysis on your system now.
Yes, I can see that at the top right corner now.
Yes, so when you want to use it for a simulation, you select data analysis and then you go for random number generation. random number generation. When you click OK, it will lead you to where we are now.
Yes, sir. I'm there now, sir. Thank you, sir.
All right. So, who is having issue? Nobody. So you can always simulate now on uniform distribution. Now let's simulate from another available distribution that is there. So this time around, I want to simulate from normal distribution. You know, normal distribution has two parameters, mu and sigma. Abi? Mu is the mean, sigma is the standard deviation. So if you specify the mean and standard deviation, then you can simulate. So a normal distribution with a mean of 0 and variance of 1 is known as standard normal. Abi? So by default, it is standard normal that the system will show you. But you can always change, just as you have in the case of the normal, uniform, that is from 0, 1. So the same thing for normal, to just present by default 0, 1. So it is now left to you to fix the appropriate figure for the parameters. Now let's simulate from uniform distribution 0, 1, 500 data point. But I want us to keep, yes, normal, yes, thank you. I want us to fix the random seed, leave it at 64 so that it will generate uniform value for us. So number of variables, maybe we should let's choose 2 so that you can have 2 columns. Number of variable 2, 500 data point, yes, mean 0, standard deviation 1. So let's change our output range. So I would delete. I want it to be at O. Okay. O. Distribution is normal. It's normal. It is standard normal based on the parameter that the mean is 0, the standard deviation 1. So then I'll click OK. So it will generate 2 different. Can you see it? Who is having issue with this? Okay. So now simulate from normal distribution with a mean of 5 and standard deviation of 24. Now let's make it practical now. Let's make it practical. So you have been engaged as a consultant, as an expert in operations research by a business mongrel, and is looking at investing in 3 possible securities. And experience have shown that the first security is normally distributed, the returns of the first security is normally distributed with a mean returns of 20% with standard deviation of 8.5. It has 3 different securities. The first security experiments have shown that it is normally distributed with a mean of 20% and a standard deviation of 8.5. The second security is also normally distributed with a mean of 20%, but with standard deviation of 6.5. The third security is also normally distributed with a mean of 18% and standard deviation of 9%. What is the maximum expected returns from each of these securities? What is the minimum of return from each of these securities? What is the median return of the three securities? What is the coefficient of variation of each of these securities? And what would your advice be to that business model? So now let's look at what we need to do. So it means that we need to simulate three different values. The first one for the first security using the specified parameter. The second security using the specified parameter, and then the third one too. And then you will now run descriptive for the three of them. So your descriptive will now show the mean, the median, the mode, the maximum, the minimum, and the coefficient of variation for each of them. And then you will compare. So your comparison will now be based on the result that you got. So if it is, your decision is purely going to be on the maximum returns, then whichever of the three has the maximum return will be the one that you will advise. The median, which represents 50% of the time that you that when you invest, 50% probability that you will have that value as a return. You can use that too, at the 50% chance that that security will produce that number as your return. You can look at the mode. That is most of the time the return that you will get by investing in those securities. Coefficient of variation, that is a measure of the risk with respect to the standard deviation. Measure of the risk with respect to the return can also be used to measure. The one with the least coefficient of variation will be a security that demonstrates or has the potential of resulting into loss. So now let's simulate from the three different distributions and then take our decisions. So I will advise that we name our distributions first. Let us name our three columns. Let's call that one security 1, security 2, security 3. So under R, so I'll call this security 1.
I use differentiate.
Yeah?
I use differentiate.
Whatever. That is security 2. You can see that my uniform is not that exact. You can see that it's changing. Security 3. So now let us simulate now. So I will simulate data analysis, random number generation. I click OK. Normal. The first one is 20 instead of 0. 20. Then 8.5 standard deviation. 8.5. Only one variable, because each of them have different parameter.
Excuse me, sir.
So random number will be 64, but output, yeah, I'll answer you now. Output, I want it to be under R, so that's where it will generate. Yes, ask your question.
Since you said 20% for the question, I was assuming 0.
If you leave it that way, I mean, you're not converting to a decimal. So whenever figure you see, you just see it's in percentage. Do you get it? So if I divide it and then make it decimal, by the time I'm done, I'll still need to multiply by 100 for me to say this percent. So that's why I decided to just leave it as it is. So I can generate that. That gives me the first I've generated. And then the second one, so you can be ahead of me if you are faster. The second one is 6.5. 6.5. The output, I'll go to security 2, and then I type enter. So I already have it. The third one, the third one, the third one is 18, 9. 18, 9.
18.9 for the mean and standard deviation.
Yeah, the third one. Then the output range, I'll change it. It's supposed to be under security 3. And then I'll click OK. So I've generated.
I didn't get the mean and standard deviation for the second one. Is
So I want the descriptive now. So let's do the descriptive. So I will go to data analysis. I choose descriptive statistics. I click OK. My data range, you can see it is there. And then I select the whole 500, which I've selected. So I will return label in first row, because all those security 1, security 2, security 3, they are all labels. And then I want my summary statistics. And then I want it to be on a new sheet so that I don't want to mix up that descriptive with data. So I will leave new worksheet ply. Then I click OK. So another sheet comes up. And then I have my results.
Thank you. The input range, sir, how do I get that?
Input range, you go and highlight the data.
The entire data on security 1.
Security 1, 2, and 3.
Okay. Okay.
Including the label.
Including the label, okay.
So you can see that the average for security 1 is 19.9%. For security 2 is 19.95%. For security 3 is 17.9%. The median for security 1 is 19.6, 19.7 for security 2, while it is 17.6 for security 3. The maximum for security 1 is 42.
42.61046.
Yes. The maximum for security 2 is 37. While the maximum for security
0.9
is 41. Then the minimum, which means the amount that can be lost. Okay. So for security 1, there can be a loss of 1.7%. Security 2, there can be a loss of 3.39.
But it's not negative there, sir.
The minimum is there is 3.39 percent returns. While for security 3, in fact, the minimum can be a loss
And
of
it's huge.
of up to 5%, but this is about 5% loss. So you can see how all of these are calculated. For the coefficient of variation, you now have to divide the standard deviation by mean before you get coefficient of variation.
Okay. There's no way to solve for that.
Will you buy what, sir?
Yeah, you can. You can just make. Let's look at what I'm doing on the screen. CV, coefficient of variation, will be equal to standard deviation, which is this, divided by the mean, which is that. That's all, times 100. So I can put percentage there.
Deviation divided by yes.
Yes. That's it. You can see the coefficient of variation can be as high as 43% for security 1. Now let me copy and paste for security 2. Security 2 can be 33%, and then security 3 is 51%. That means in terms of risk, one should encourage the business mogul to go for security 2, because security 1 can lead to loss.
Okay.
Of the 3 of them, it is only security 2 that have not exhibited loss. Because the minimum for security 2 was 3.4%, while for the other 2, the business can actually experience loss.
But based on the CV,
Mhm.
we can't judge based on the CV to give an advice.
You can, but risk and returns, they go hand in hand. If your risk is high, your returns will be high. You get it? Most of high yielding securities are very risky. And that's what you can see here. 43% is a bit high. And security 3, which is 51%, is not even producing a mean return that is as high as security 1. So yeah, so let's simulate from other distribution. The challenge here is you can't even simulate from exponential. Exponential is not available. It's not available. Let's go back.
Sheet 1.
Let's go back to sheet 1, and then let's open the bit analysis, random number generation. Click OK. You can see after normal, because you have binomial, you have Bernoulli, you have Poisson. There's no exponential there. There's no log normal. There's no do you get it? There's no log normal, there's nothing. So let's just let's simulate from Poisson. Are we done? So want to simulate Poisson. Poisson has one parameter, lambda. Lambda is the mean, lambda is the variance for Poisson distribution. So let's simulate from Poisson 5. That means the lambda is 5. So I'll just put 5 there as the lambda. And then I want you to be on that page. So let's go and click on V. Under V.
I've used V, so now we'll use Z.
So you can just,
So it is the same variables, the same random numbers, 501.
yes, it's 500. It's 500.
Then same random seed.
Mm.
64.
So you can see that the values are whole number. Why are they whole number? Because Poisson is discrete. So I want you to simulate from Bernoulli. I want you to also simulate from binomial. So simulate from Bernoulli 0.8. I want you to also simulate from binomial n equals to 10, p equals 0.5. Yeah, simulate.
N equals
N equals 10, p equals 0.5. The first one is simulate Bernoulli 0.8, p equals 2.8. You know, Bernoulli is Bernoulli binomial, they are discrete. Normal, uniform, they are continuous.
So there are all numbers also.
Yes, there has to be a whole number.
Whole number. Nine. What is
So they're all
full number.
Àwọn mi. Àyè máa ń ṣeré yẹn.
lọ pé arúgbó ṣomidan rí.
Bẹ́ẹ̀ ni, ọmọ. Ọmọ rárá. Gọ́dọ̀gọ́ tẹ̀lé fígbà tiwa yẹn. Ṣé kò tí ì sí gbogbo nǹkan máa gbé laptop máa rìn kiri?
Bẹ́ẹ̀ni.
Àwọn alájọ́ kò sí kọ̀mpútà laboratory.
Project students?
I don't do any ask. Are you a project student? Yeah, this is the
Okay. I need to finish my class. In fact, I all right. So let's look at that distribution. You know, this has a lot of let's see, you know, this you are constrained with what's available in your Excel. Okay. But in real life, that can be normal, can be can be Pareto, it can be gamma, and you don't have gamma in all of this. I still want to. It can even be exponential, and this doesn't have exponential. So let me introduce you to the quick fit. Just watch what I'm going to do.
From that.
Okay, so let's simulate from I'll simulate from 3 different distributions. I'll simulate from exponential, from gamma, from log number, maybe from Weibull. Okay. Then I can also fit data to it now. Those data that I already have, I can copy them, I put them into this environment and test. And say, okay, fit data to this, fit distribution to this data. So what will you?
So does this have the explanation?
Yes, it does. You can see, Nabi.
Yes.
So, and if you are feeling choky, you can open the door.
You get it to the side.
No, I gave you the link now in this thing that you should download. So, but let's just quickly, let me just show you so that we can go to
Hello, sir.
statistical methods.
Hello, sir.
Hello, yes, someone
Yeah.
is trying to.
Yes, the Quick Fit Pro that you launch now, is it part of Excel or is
It's not an Excel.
the separate
At the
house?
beginning of the class, I gave us an overview of everything that we needed, and I asked students to go and download the trial version, which we did. The student downloaded the trial version, and everybody was using it. But I have the full version, so I can teach with it. So just watch what I'm going to do.
Okay, sir.
So I want to simulate so I can generate data. Okay, please just watch what I'm doing. So I can specify the distribution. Remember, I want to simulate from exponential. So let's say I want 500, same 500. Okay. So, and then, yes, I want it to be under variable 1. So I can ask it to proceed. It will ask me for the parameter. So the parameter is, let's say I'm simulating, let's say the rate is, let's say 4.5. Okay, 4.5. All right. And then I'll generate. So you can see it has generated it. So it has generated. So exactly the way the Excel works. So that's how it works. But the difference here is that it's a different environment. Unlike the Excel doesn't have exponentials is an option. So the trial version, I know it works for normal and Python. Okay, so let's do the for gamma. So You know, gamma has two parameters. So variable 2, that means I want it to be under 2, column 2. I also want 500. And then proceed. So it requires 2 parameters. So let me leave it as the shape is 3, the height is 4.5. Okay. And then I will generate. So you can see it will generate. Then the same for log normal, for any distribution, it will just be generating. And then when it comes to fitting, that means I have data. I want to know which distribution does this data come from. Excel doesn't have that functionality, but this quick fit has. So let me go and copy from our uniform 0, 1. So let's go and copy from the securities. Remember our security 1, 2, and 3, Abby? Yes. So let's copy from security 1. Security 1. Okay. Let's copy from security 1.
Yes, it's not. No, it's not working. Because it's not full. It's working, but
we'll do for normal now. So that you two can, we'll do for normal, we'll do for Python, at least the one that you can work. But let me just show you how to fit. And this normal you can fit now. You can copy from that security 1 and put in there and fit normal. You can fit normal. So I can paste, Control V. So I have pasted from security 1. And then I asked it to fit. You will see it at the top. Please mute yourself. You know how to. So analyze. Have you seen analyze? Fit distribution, which I can fit. Your own will not have all the other metrics, ESG, financial. Your own will not have that. So now I want to fit variable 3. Variable 3 is the security 1 that so, and then I select. Remember, in your own case, you can only select normal. Otherwise, it won't fit the others. Just select normal to fit normal. Now, you will notice that the system had already normed some other distribution that are not active. What it means is that by default, that quick fit had already screened distribution that data can fit. So that's why the others are normed. That, for example, it can't fit it can't fit beta, for instance. Beta, beta 0, 1 is between 0 and 1. Any value that is outside it, that means it won't fit. So it will have already normed it. You can't fit Poisson. Poisson, it has to be whole number. You can't fit Bernoulli. You can't fit Bernoulli. So that's why you see all of them normed. The one that is active are the one that it can fit. But since you have the trial version only, just select normal. And then when you click OK, it will fit it. Can you see it? What meal did he give you? 19 point. And then the standard deviation is 8 points. So which means you can see that it's very close to where you simulated from. Remember, we simulated from uniform from normal 20 and standard deviation 8.5. Remember? So at least that means this is representing your data to a large extent. So in case if you have a raw data, and I said fit the distribution to that data. This is exactly what we mean. Get the histogram and then try and fit the curve to it, and then tell us what distribution best suits it. Because with that distribution, you can calculate. I can do the CDF cumulative distribution at the top. Just be clicking at the top. You can do the CDF. The CDF can assist you to calculate the cumulative probability. So then you have the survival function. You can assist you to calculate the probability that X is greater or equal to some number. You can do the hazard function. Hazard function, which is the ratio of your CDF and the survival function. You can do the cumulative hazard function. You can do the PP plot. You can do the QQ plot. And you can do the calendar plot, which is also known as the plot. That's what this can do.
That PP plot,
the probability plot.
okay.
QQ plot. That's also the probability plot for testing the quantiles. So quantiles are like the percentile. And the beauty of it is, if you let's say you minimize that, I can compare. If you go to the tool, okay, where you distribution explorer, since you can do normal, let's explore the normal distribution. At least you can do normal. So let me select normal. So I want to see the shape of those three different securities. Let me do normal. How you are watching me, so you can see normal. This is normal 0, 1, Abi. Now, the first security is what? 28.5. I can say add. Can you see it? So I will change the mean to 20. I will change that on to 8.5. Can you see? If you compare that to normal 0, 1, you can see that they are different. Now let me add normal, the second security, 26.5. So let me just change the first one to 26.5. That 0, 1 to 20, then 6.5. You can see that the one of 8.5, which is pink, has a wider variance. Look at the base. You can see that the base is wider. Right? Now let's now do 17 what?
18.9.
18.9. So let's just add 18, then 9, 18, 9. So in diagram, you can always add your investor. So you will see that the one in blue appears to be better behaved than the rest, because it's more compact. You can see that the majority of the data are within a confined space. They are not as spread as the one for pink or the one for green. So, you can go and explore more simulation on your own. You can go and explore fitting data, get data, fit it, because I will give you assignment. The assignment will require you that you get plenty of data. And then you explore it, and then give me your insight. With evidence, not that you just go and give ChatGPT and then you start submitting. So maybe we should have a break like 10 minutes, then we do the statistical method where we test hypothesis. One sample test, two sample test, 3 or more sample, and then we do regression. Regression analysis. Yeah, sir.
Okay, then I want no bear. I want no bear. I want move number to Mumbo. I will move. I want stars to see it. They were walking down a lot of way. What I want the program in auditoriums. What I think Professor Diallo. Okay. Yeah, the role of program. So the might get the program. Oh, where is the man? Break time. 10 minutes more. Not today.
Area is not yet. It's James now. It's James now. Area is not yet. And I'm here. I'm single.
Sir.
Yes.
I want to
Any oh,
data that went for
okay. Have you got it? What did they say?
that they just said no. Then we explained to them
And
and showed them our letter. They said they cannot see like
you went to only one place.
we went to
Ah.
and the other ones
We'll
somebody will be between
get data. You got, don't worry. NHI, they'll give you data. Don't go to only one insurance company.
just
Keep,
like
exploring.
our letter carries their own address.
So you can tell them to give you another letter. I will sign it. That's why you should make it to whom it may concern. Don't address it. Yes. Or you will get. You started marketing. Started marketing. So someone will turn you down. That's nice. But eventually
We people try to persuade them. They're going to call people to come and talk to us. They came, we persuaded, they told us to hold on.
it's part of it. It's part of it. Go and tell them to address it to wherever you want. Try to make it to whom you concern.
Is it possible to get like maybe like 2?
Yes. Tell them to do it now, so I'll sign it. After all, today is project.
Today is the project.
Wait first.
Yeah. Well,
Why you laughing?
Today we want to see the one.
That is there any way you can tell us to go to chat? They just answer this.
you are learning. You are learning.
Sorry,
Go and do it yourself.
We are
You're spending money. No, talk to your parents. They will refund you. They know the money that you are spending is for a genuine cost.
That friend that you can call.
Nah, don't worry. Call your uncle. Call your brother.
They
all know. You're the firstborn.
I am first.
It's okay. You are the only child. Don't call your brother, your father's junior brother.
That should we come back? Maybe there's any way that you
My
can recommend
quite
us.
simple.
So let us finish our own.
Meet them at the departmental before they go to prepare the letter to whom it may concern. And you should bring it.
Back.
And you bring it now, I will sign it.
And you recommend us to somebody.
No, I'm not recommending now. You have to put in your effort. That's how to train students.
So we do like 2 more places that they know answer us.
They will answer you.
So regarding my data, the company that we start to say they don't have data up to 5 years.
The one that they have let them give.
And all the products have to work. It's only like so.
Keep trying. These are that you have. Let's see it.
Okay, sir.
Thanks.
Thanks.
Sure.
Very good. No, no. No, no, they didn't do that. So, nothing was really good.
The first one, this one like that. Yes. Okay, so let's start. Let's continue. 10 minutes is over.
Yeah, I'll see you for.
So let's do correlation analysis now. And we'll do correlation analysis, we'll do regression analysis. We'll try and do time series. We will do exponential smoothing, moving average. Then we'll now do test. So I will go back to the sheet one, where I have security 132, security 3. So let's investigate whether or not the 3 securities that the business will go on to investigate are in any way related. So we want to investigate their level of association. All right. So, um, our correlation analysis. So we know that correlation is a study of a relationship between two variables. And if you have more than two variables, the relationship among You get it? So you guys should meet among yourselves. Since it's an online class, you let me know when best to fix the class that we can have our last class. So on that note,